In part 1 of lesson 22, titrations, it talks about the definition of a titration. It's for using a neutralization reaction to figure out the molarity or concentration of an unknown acid or base. Like we did in yesterday's lab. We had a known amount of base, but we had to solve for the unknown molarity of the acid. Two terms come up in this section in your book. One of them is equivalence point. That's when the bromothiamyl blue indicator turned green. When it goes from yellow to green, you know that you've added enough hydroxide ions to where the number of hydroxide ions or the number of moles of hydroxide ions equals the moles of hydrogen ions. Again, the second term here in this section is the word indicator. That is a chemical that's used to detect the equivalence point by color change. So again, bromothiamyl blue, universal indicator, or the pH strip are all examples of indicators. In part 2 of this reading, it talks about particle views, and it has pictures of drops of water. I want you to think of those drops as volume. So they give you 1 molar solution of HCl and a 1.0 molar solution of sodium hydroxide, 1 drop of each. And then they want you to figure out how much sodium chloride you have at the end. Well, technically, you would also get a 1 molar solution of NaCl. However, because, and I don't know if you can tell from my drawing of my doubly large sodium chloride drop of water, but notice my end result here, the drop is supposed to be twice as big. So because of that doubling in volume, the concentration of the sodium chloride is half the molarity. Right? It's kind of like if you as a student, all of a sudden, this room were to expand to twice its size. If you have twice as much room in here, then the concentration of students would go down to half what it was. This is a little messy, but I'll try to use my little red cursor to help you get through this. All right. So the question in your book is, what if you have a 2.0 molar sodium hydroxide drop? So here's your drop of acid, 1 molar, just like in the previous example. This time they give you a drop of sodium hydroxide, but it's double the number of molecules in the same size drop. So what's happening is the 1 sodium will combine with 1 chlorine, again, just like in the previous problem. And what happens there is, because it's, again, the drop is twice as big now, volume-wise, it's cutting the concentration to half a molar. All right, so normally you would think that you would start with a 1 molar solution of hydrochloric acid, then you should form 1 molar of NaCl by way of the balanced equation. So up here, sorry for my scribble scratch, my balanced equation is a 1-to-1. So what I'm saying is 1 hydrochloric acid molecule will make 1 sodium chloride molecule. And the issue here is, if you realize that this is this is an excess reactant, then, because you have actually 2 molecules of NaOH here, and only 1 is going to get reacted with the acid. So what that tells you is this hydrochloric acid, the one getting used up, is the limiting reactant and is going to control or predict that only 1 mole of sodium chloride would form. So we know this is 1 because this is 1 and this is 1. So one of these makes one of these. Therefore, if you lose one, you make one. All right. Again, let me reiterate. Since a mole of sodium chloride forms, but it forms in 2 drops, so you can kind of divide 1 mole by 2 drops, and you can kind of get a half a molar. Now I know drops aren't liters, but I'm kind of considering them here as if they are liters, and it makes it easier to do this problem without too much calculation. I hope you guys understand this. Okay, on the last problem here, this one's kind of confusing, but what if you have to do some heavier calculations using titrations? Well, this is a balanced equation right here of sulfuric acid with sodium hydroxide. Notice the 1:2 ratio. The question in your book, and you kind of have to have read the question in your book prior to going over this, otherwise it makes no sense. The question in your book asks for you to solve for the molarity of this acid, knowing the volume of acid that's being combined with a known molarity and volume of base. That's how titrations usually work. So here's what you do. You can look at this column and see that we can work out moles, because molarity times liters gives you moles. Well, you know that since this is a titration, that the number of moles of H and OH have to be equal, right? Because titrations go to pH 7, and at that point you have equal numbers of H and OH. It's the whole concept behind titration. So if in fact in this column where we know everything, we know that we have 1/10 of a mole of NaOH or hydroxide ions, then we should make 1/10 of a mole of hydrogen ions. But since there's 2 moles of hydrogen ions per mole of this acid, then we can say that there's 0.050 moles of acid being reacted. That still comes out to be equal moles of H plus with this. Slightly confusing, but notice the 1:2 ratio. Right? You'll have to go back and look at this again. Well, anyways, since we know the moles now of the acid and the volume of the acid, to get the molarity, all we do is divide the moles of acid by the volume. So down here I do this. The molarity of the H2SO4 is the moles of the H2SO4 divided by the volume, and there we go. That's it. See you later.